Hi everyone, we're going to find the integral of secant cubed x dx, and we're going to use integration by parts. So the first thing I'm going to do is let's use our u substitution for integration by parts. And if I rewrite this, I'm going to rewrite this as secant x times secant x squared dx. So now when you do that, let's use our u, find our u and all this information. So we're going to let u equal secant x. Therefore, du equals secant x tan x dx. Then we're going to let dv equals secant squared x dx. Therefore, v, the antiderivative of secant squared, is tan x. Now I can use my formula. We're also going to use this formula here. This is going to show up. And so I'm going to attach the video that I already did on this at the end. But you need to know this formula here. So basically, let's get started and use our integration by parts. So we're going to get, for this is your u, and this is your dv, is everything else. So using the formula, we're going to get this equals secant x tan x minus secant x tan, I need to move this over. I'll fix that in a minute. So tan squared x dx. Okay, this was du right there. All right. Now, simplifying this further, we get this equals, I'm going to move down, secant x tan x minus the integral of secant x times, and I'm going to take my identity for tan squared of x, my Pythagorean identities, and write this as secant squared x minus 1 dx. All right, and then I'm going to distribute. So we still have this equals secant x tan x minus, now when I multiply these two, I'm going to get the integral of secant cubed x. And then I'm going to go ahead and put this in brackets, minus, when you distribute here, secant x, now put an integral in front of that. And this whole thing is dx. So I went ahead and did two steps. I distributed, and then I broke up the intervals. So this is going to end up being, and I'm going to rewrite it, when you distribute the negative, you're going to get secant x tan x. And again, this is for our integral of secant cube x dx. So minus our integral of secant cube x dx plus the integral of secant x dx. Now, we already know, so let's write this out. Minus this integral, equals secant x tan x. All right, then I'm just going to copy this part down. Integral secant cube x dx. And then I'm giving you this one. So if you take the antiderivative of secant x, you're going to get plus, I'll put it down here, ln of secant x plus tan x, and this is going to be plus c. Now the problem we have is this part right here. So what I'm going to do is I'm going to add it to both sides of the equation. So if I add it to this side, it'll go away, and I'm going to add it here. And that gives us 2 secant cube x dx equals secant x tan x plus ln of secant x plus tan x plus c. And then the only thing else we have to do, and I'm going to go ahead and just erase it here. I have this 2 here. So I'm going to divide both sides by 2. So that means I'm going to put a 1/2 here and just put it over the whole thing except for the C part. All right. Integrals like this one may seem special, but they occur frequently in applications of integration. So this one is a really good one to know. Thank you. Have a nice day. Bye-bye.